George and Paul play a betting game. Each chooses an integer from 1 to 20 at random. If the two numbers differ by more than 3, George wins. Otherwise, Paul wins. Calculate the probability that Paul wins. So Paul wins if the difference will be less than or equal to 3. So if the absolute value of the difference of x and y is less than or equal to 3, where we're calling x and y to be the numbers that the two persons select. So now, since each person has 20 options, so the total options for the two, it would be 20 times 20 equals 400. So this is very similar to rolling two dice, where we have 6 times 6 equals 36 possible outcomes. Here it's 20 times 20 equals 400. So now we're looking for the xy pairs where the difference is less than or equal to 3. So when x is 1, y could be 1, 2, 3, 4, because all these values, when you take their difference from 1, that's less than or equal to 3. Similarly, for x equals 2, y can be 1, 2, 3, 4, or 5. These numbers differ from 2 by 3 or less. Similarly, for x equals 3, we have 1 through 6. However, once you hit x equals 4 and all the way up to 17, then you can have 3 numbers below 4. I mean, for example, let's say when x is 6. So you can have 3 numbers below 6. You can have 3 numbers above 6. And you can have 6 as well for the y. So there'll be 7 total. So, and that will work for all of these, because for all the numbers 4 through 17, we do have enough room to select 3 numbers below and 3 numbers above. Remember, our limitations are 1 through 20. So if you note, the 1, 2, and 3 don't have enough room below them. You can't choose 3 numbers below 3, for example, because there aren't. You can only go 1 and 2, which are below 3, because you can't be less than 1. But for 4 through 17, you have complete freedom. You can go 3 below, 3 above, and also the number itself. So each of these 4 through 17 will bring in 7 pairs. And now between 4 and 17, there are 14 numbers. And each of these 14 are bringing in 7 points. So these will bring 14 times 7 equals 98 more points besides these. And then we are left with 18, 19, and 20. 18, when x is 18, y can be 15, 16, up to 20. So these are 6 points. And then for 19, it could be 16 through 20. And then when x is 20, then y can be 17 through 20 to have the difference 3 or less. So now 4, 5, 6, then 98, and then 6, 5, 4. Add all these up, and the probability of Paul winning would be all this sum, because all these are the sums, are the pairs where the difference is less than or equal to 3, divided by the total of 400 pairs. So this adds up to 128. So it's going to be 128 by 400, which is 0.32. And the correct answer was B.